students. Today I am going to talk about relative angular velocity. So linear velocity we have already studied, and relative linear velocity, that too we have studied. Now what is angular relative velocity? That concept will have to be understood. So if you remember, I had discussed that for any kind of curvilinear motion, suppose there is this kind of motion, and observation is being done from here, from A at this position. Suppose this is r vector, right, and this is the velocity vector. Then if this velocity is resolved in two different directions, one along this radius vector, another is perpendicular vector, and if this angle is theta, that is v cos theta, and this is v sin theta by magnitude. This velocity and this velocity are independent. The function of this and function of this is different. When it is moving along this path, the object is moving, and suppose this is the observer over here, it comes to position B, right? So two things are happening. Its radius is increasing. Suppose it is R1 vector, so radius is increasing as well as this theta also. This way also angular displacement is also there. So this velocity causes angular velocity, angular displacement, and consequently angular velocity. Since angular displacement is there, the angular velocity is there. So it is caused by this velocity component, and this increases the radius. So this I had discussed, that normal to the distance between the observer and the object, normal velocity gives the angular velocity. That is why we write angular velocity is equal to v perpendicular by r. This is the formula I had derived. Now today I am going to talk about relative angular velocity. If you remember, in case of relative linear velocity, what concept we had used? So in a plane as well as linear velocity, that too we had done. Suppose this is the object A and this is the object B. This is moving with velocity VA, right, in this direction, and this is moving the same direction with velocity V. Then I am talking about the linear velocity, rectilinear motion. So if I say velocity of B with respect to A, velocity of B with respect to A, then we write VB minus VA for the linear motion, because linear motion, it is direction is decided by plus or minus. So this was the condition, VB minus VA. So first we bring it to zero velocity. So minus VA we do over here, then it comes to rest. Then minus VA we write over here. The VB minus VA is the net velocity of B when A comes to rest. A comes to rest. Then whatever velocity of B is observed, that is called the velocity of B with respect to A. If it is not, velocity is not along the line. Suppose this is P moving in this direction and Q is moving in this direction. Two different directions. This is VP and this is VQ. With these velocities, they are moving in two different directions. So what will be the direction of Q with respect to P? So what we are supposed to do, we will put, that is VP opposite direction to keep the condition same. This Vp will have to be put on this also. The P comes to rest in this condition. The Vp in this direction, opposite velocity is given in this direction, so this comes to rest. At that time, whatever velocity of Q we are getting, that is the relative velocity of Q with respect to P. So vector sum we will be doing, so this will be added and this is the resultant of, and of course this is minus Vp, Vp is in this direction, this is minus Vp. So this plus this means velocity of Q with respect to P is vector sum of Vq minus Vp. That is vector sum. So this velocity is what was Vq minus Vp. So this way, how to find the relative velocity of linear motion? Same fashion, same concept will be used for finding the relative angular velocity, but here perpendicular velocity will be taking with respect to r. Then how to write this? अगर ऑब्जेक्ट एक केस लेते हैं A, this is the position of the observer and this is the position of an object which is moving in this direction with velocity Va, right? Now, what is the angular velocity of this B? Right, it is B. Angular velocity of B with respect to A. What do we do then? We join this. This is R vector, extend, direction is this. If this angle is theta, as I have done over here, so perpendicular component means this component of velocity, that is Vb cos theta in this direction, Vb sin theta in this direction, this is 90 degree and this length is mod of this is equal to r. Then we will say angular velocity of B with respect to A. Now it is at rest. Observer is standing and observing. So instantaneous angular velocity in this direction, instantaneous means d theta by dt. So omega is V perpendicular upon r, that is Vb sin theta upon r. And what is this? Angular velocity of B with respect to A. Now A is at rest. At rest. When it is at rest, then this is the angular velocity of B with respect to A. Second case, what will be there? Suppose this is A and this is B, which is moving in this direction with Vb magnitude, and this is moving with Va in this direction with Va magnitude, perpendicular to this. Now we have to find what is the angular velocity of B with respect to A, right? Angular velocity of B with respect to A as I had done in this case. So condition is this only as for the 1D motion, 2D motion, linear motion. In the same way for angular motion also, A will have to be brought to rest first. So for that, opposite velocity I will give, that is minus Va by magnitude. It will come to rest, at rest. Same velocity will have to be given to this also, that is Va by magnitude. Direction is shown by magnitude if I am seeing Va in this direction. Now this has come to rest, then whatever total velocity which is perpendicular to this r will be causing the angular velocity. So here two velocities are there, Vb in this direction making angle theta. So by magnitude, that is VB cos theta, and in this direction, that is VB sin theta. So perpendicular to R, which are the velocities? VA plus VB sin theta by magnitude. अब देखो इसको पहले रेस्ट में ला दिया, रेस्ट में रिलेटिव वेलोसिटी वी आर ट्राइंग, रिलेटिव वेलोसिटी ऑफ बी विथ रिस्पेक्ट टू ए हम फाइंड आउट कर रहे हैं पहले। रिलेटिव वेलोसिटी ऑफ बी विथ रिस्पेक्ट टू ए फाइंड आउट करने के लिए लीनियर वेलोसिटी बोला था, वेक्टर एडिशन वी डू। सो माइनस वी इधर कर दिया, माइनस वी इधर लगा दिया, वेक्टर सम अगर लेते हैं तो इसका एक कंपोनेंट ये ले लेंगे हम, क्योंकि हमको नॉर्मल पर ही एंगुलर वेलोसिटी मिलता है। दिस कंपोनेंट हैज नथिंग टू डू विथ एंगुलर वेलोसिटी, सो हम देंगे नॉर्मल कंपोनेंट। कंडीशन इज दिस शुड बी एट रेस्ट, देयरफॉर VB omega B with respect to A, V perpendicular by R, that is equal to, V perpendicular is this, that is VA plus VB sin theta by R. This is omega BA. This is also very good and very important relation. Perpendicular, direction is perpendicular. Second case I will take when it is not perpendicular, making some angle with R. अगली possibility क्या हो सकती है? Is suppose this is A, this is B, this is R. Its direction is, suppose in this direction, this is B, that is VB. With this magnitude it is going, and this is moving with this magnitude, that is VA, making some angle theta. Suppose theta 1, and this is making an angle theta 2. So we have to find angular velocity of B with respect to A. In the same fashion, vector component we will be taking. So just opposite direction, VA velocity is given, and this comes to rest. Opposite velocity, same velocity will have to be given over here also. Same angle. We suppose it theta 1, 180 minus theta 1. So this angle also it will be 180 minus theta 1. So this will be theta 1. This is 180 minus theta 1. Right? When opposite velocity is given, this comes to rest. It is very important. Comes to rest. Same velocity will have to be given to V also, as we have been doing to find the relative velocity of B with respect to A. With respect to A means A will have to be brought to rest. Now it has come to rest, then normal component of these two velocities will give the angular velocity. See, in that case, two components will come. VB cos theta 2, it is VB sin theta 2. Here VA, in this direction, VA sin 180 minus theta 1. In this direction it will be VA cos 180 minus theta 1. And sin 180 minus theta 1 is sin theta 1. So VA sin theta 1, and this is VA 180 minus theta 2 minus cos theta 1. So perpendicular direction, if you look at, this is 90 degree, this is 90 degree. Net velocity, this minus this or this minus this, net magnitude we will be taking. So we will write omega B with respect to A, V perpendicular by R. So V perpendicular is what? Magnitude. Magnitude of this. This is the magnitude only, but positive or negative, that will be decided. So we will write VB sine theta 2 minus VA sine theta 1 by R. So this is the angular velocity of B with respect to A. So direction will be decided which one is more. If this quantity is more, direction will be moving like this, right? If this is more, it will be moving like this. It depends what kind of magnitude is this. So this way we have found how to find the relative angular velocity of one object with respect to the other. एक इस तरह से भी कर सकते हैं. This is A, this is B, right? And this is the velocity, this is R, this is theta, this is VB, and it is theta 2 suppose. And suppose VA. A is moving in this direction, make an angle theta 1. Relative velocity of B with respect to A. Same procedure, make the velocity 0 in opposite direction VA. So here in the same fashion, in opposite direction, that is VA. This theta 1, this will also be theta 1. Draw normal. In this direction, in 90 degree, whatever velocity is there, that will decide the angular velocity. So this component, if you take, it is V1, it is sine theta 1, and for VB plus VB sine theta, it is VA sine theta 2. Net velocity in perpendicular direction to R when A comes to rest is at rest now. Initially it was moving VA, opposite velocity is given in the sense, for the sake of understanding, that we have to bring this at rest. If this is coming to rest, means opposite velocity is given. So same velocity will have to be given to B also to keep the situation same. So vector sum, this and this will give the, and perpendicular direction will decide the angular velocity of B with respect to A, as I did in the previous example. So VB sine theta 1 by magnitude, VA sine theta, VB sine theta 2 and VA sine theta 1. Total velocity is this. So this velocity will decide the angular velocity, that omega B with respect to A, that is V perpendicular by R. So V perpendicular is this. So VA sine theta 1 plus VB sine theta 2 by R. This R is also relative displacement, means instantaneous we are taking. So these two positions are, there is no change in the linear direction. So if it is brought at rest, so if you are taking this component along this and this component along this, and net velocity along the tangent. So with passage of time, it will increase R, but instantaneously if you look at this, R is fixed, that is called R B or B with respect to A, that is R over here. So this way, how to find the relative velocity of one moving object with respect to another moving object is this. So one question I will take, question number 1. So this is the question. This is one object A, another object B. B is moving in this direction 5 meters per second, making an angle 30 degree with line joining AB. Then what is the angular velocity? Omega of B with respect to A is what? Right? As I told you, the component of this perpendicular direction will have to take 5 sine 30 degree, and that is 5 cos 30 degree. Nothing to do with this velocity. This velocity will decide the angular velocity. 5 into 1 by 2, that is 5 by 2, right? So therefore omega, since it is at rest, we can write velocity of B with respect to A. or simply omega we can say, because A is not moving. When observer is not moving, then simply we can say the angular velocity. When A is also in motion, then question of relative velocity comes, right? So we can say this is simply omega. Omega is equal to V perpendicular by R, that is 5 sine 30 degree by 2, and 5 sine 30 is 5 by 2 by 2, that is 5 by 4, that is 1.25 radians per second. That is the answer. Second question I will take. Here A was at rest, so I will take another question where A is also in motion. P is one object, Q is another object. P is moving in this direction, making 30 degree with R. R is equal to this, and Q is moving in this direction, making 45 degree with direction of R. So we have to find angular velocity of Q with respect to P, because both are moving now. Angular velocity of Q with respect to P in this case. So two ways are there. We can resolve this in this direction as well as this direction. Similarly, this can be resolved in two directions, this direction and this direction. So if you resolve this, that will be 5 sine 30 degree in this direction and 5 cos 30 degree in this direction. Likewise, here 10 under root 2 sine 45 degree in this direction and 10 under root 2 cos 45 degree in this direction. So vertical direction, if you take, the relative velocity in this direction with respect to this will be what? This velocity of Q with respect to P in perpendicular direction will be 10 under root 2 sine 45 degree minus 5 sine 30 degree. Now both are in the same direction. Relative velocity of Q in this direction with respect to P in this direction. So in perpendicular direction we will have to make its velocity 0. Means opposite velocity will have to be given to this. Isn't it? So we can write 10 under root 2 sine 45 minus 5 sine 30 degree. So that is equal to 10 under root 2 into 1 upon under root 2 minus 5 into 1 by 2. This under root 2 will go. So 10 minus 2.5. This will be cancelled at 0.5 times. That is 7.5 meters per second. Therefore, that is omega Q with respect to P is equal to VQ P perpendicular upon R, that is 7.5 upon 3, right? That is 2.5 radians per second. It is the first method. Same question I have taken in different way. जैसा हमने आपको बताया था वो मेथड यूज करके भी कर रहे हैं. यहाँ पर हमने यहीं पर रिजॉल्व कर दिया था दोनों. यहाँ पर इसकी वेलोसिटी हम 0 करेंगे, मीन्स अपोजिट वेलोसिटी हम इसमें दे देंगे, दैट इज अपोजिट डायरेक्शन में वीपी दे देंगे. तो ये रेस्ट में आ जाएगा, रेस्ट में आ गया. अब सेम वेलोसिटी इसको भी देना पड़ेगा आपने, दैट इज वीपी इधर देना पड़ेगा. ये है 30 डिग्री, दिस इज पैरेलल टू दिस, दिस विल आल्सो बी 30 डिग्री. ठीक है, इसके पैरेलल इसको कर दिया. दिस हैज कम टू रेस्ट. Now vector sum of these two velocity perpendicular direction will be deciding the angular velocity. अब इसको रिजॉल्व करेंगे इस डायरेक्शन में, परपेंडिकुलर डायरेक्शन में, इसको भी रिजॉल्व करेंगे परपेंडिकुलर डायरेक्शन. इधर क्या हो जाएगा 10 अंडर रूट 2 साइन 45 डिग्री. इधर क्या हो जाएगा वीपी इज इक्वल टू हाउ मच, दिस इज 5 मीटर्स पर सेकेंड. सो 5 sine 30 degree in this direction. So net, this is opposite. So this minus this will be the net velocity. So I will say that V Q perpendicular, of course that will be with respect to P, is equal to under root 2 10 under root 2 sine 45 degree minus 5 sine 30 degree. that is 10 under root 2 into 1 upon under root 2 minus 5 into 1 by 2. So this will go again 2.5, that is 10 minus 2.5, that is 7.5. So this, see, now it has come to rest. Net velocity of q with respect to p in perpendicular direction is this. Therefore, omega q with respect to p will be equal to velocity of q with respect to p perpendicular by r, that is 7.5 by 3, that is 2.5 radians per second. This is the answer. Both the method you can resolve over here only, and you can take relative velocity of q with respect to p in perpendicular direction, or here only you just make it at rest and vector sum of these two velocities in perpendicular direction will also give the same angular velocity with respect to the other one. So this way concept I made it clear. So we will take up some more problems also on this, and in circular motion new concept will come in the next video. Till then, be happy, be healthy, be fit, study consistently, and love your parents, respect your parents. All the best.